So by the end of this, the goal is to get used to be able to use something called the fetch API, which is just a nice way of being able to make network calls. So if I want to go to a particular website and get some information from them, usually in the form of JSON, and I want to use that within my own web application, then that's how you do that. But I think in order to maybe to have a deeper understanding of what's happening, we kind of have to take a step back. So most of what we'll talk about now is it's conceptually difficult and strictly speaking, not really necessary, but we'll talk about it anyway. So I'm gonna give a quick example, share my screen. So let's say we have something like console start. And then is anyone familiar with set timeout functions? I get some autocomplete. So set timeout is a built-in. This is part of like the web API. So it's not, strictly speaking, it's not a part of JavaScript, but it's something you can access from the browser. So set timeout will take it takes two parameters. It takes a callback function, and then it takes an integer, which will be however long in milliseconds you want to wait to execute the callback function. So the first thing, we can have a callback. So we'll just do and let's execute that after 3 seconds. So 3000 milliseconds. So I can run this. Okay, so I get start, and then, roughly, or at least 3 seconds later, this gets logged to the console. Has anyone seen set timeout before? Okay. So let's talk about how this actually works. So the first, your application starts here, right? It gets executed top down, more or less. So comes here, this set timeout function gets executed. Set timeout. So one question is, if I have something on line 7, what am I going to see printed as output?
Well, after the 3000 milliseconds, you're going to see end.
Okay. So I'll get start, and then inner console log, and then end. I mean, that makes sense, right?
It seems kind of weird that they would have the set timeout work that way. Like, wouldn't that screw up stuff by default unless you knew that's how it worked?
Can you elaborate a little bit?
So if you didn't know that it would not move on to the next line of code when you leverage the set timeout function or module, whatever it's called in JavaScript, well, that would hose up any time you use it in terms of processing all the lines of code in your script or your file. It seems just problematic with like a default library or whatever that thing's called.
Yeah. So so if it's the case that this line executes and then this line executes, or these lines execute and then this line executes. So yeah, so if it executed that way, then our application would freeze for 3 seconds, right?
Yeah, that seems problematic, which is
Yeah. Yeah, it would be. So imagine if this were like a network call or something. So we want to log in a user or maybe grab some information or do whatever. And let's say maybe there's some issues with the network and it takes 3 seconds maybe to return a response. So for those 3 seconds, the user isn't going to be able to do anything on the web page. Can't click a button, can't scroll, can't really do anything. So that would be very, very bad from a UI or a user experience perspective, right? So you definitely do not want to block things. So let's go ahead and execute this code and see what actually happens. So it starts here, prints out start. Then these lines, so maybe it just skips over them and then executes this and then executes this later. It's not clear what's actually happening, but we can see that we get start end, that happens immediately. And then after 3 seconds, we get inner console log. So let's talk about why that happens. So JavaScript is single threaded. So it's single threaded. We don't really talk about threads in this program, but there are other languages, Python, where you can create threads, kind of like multiple independent processes or sub processes that can do actions independently at the same time. So you can do multiple things at the same time. JavaScript doesn't work that way. You can only ever do one thing at a time. But if you can only ever do one thing at a time, this obviously could create problems, right? Where you're blocking, especially for network things or IO operations, reading from a file, making a request to some other backend service or whatever. So most of the time in a web application is going to be spent not processing, but just waiting, basically. Make a request, wait, get a response, do some processing, make a request, wait, right? So the way JavaScript handles this, that it kind of divides this up. So it in some ways it's like cheating a little bit, but we have the call stack, which we're all familiar with, right? So if we have a bunch of functions, line by line, one function gets called, it gets put on the call stack, and then once it returns, it gets pulled off the call stack, right? So things get added on to the stack and then pulled off. And if you have recursion, you can get lots and lots of things on the stack, right? So we're all familiar with that. So JavaScript and the web, so node APIs or the web APIs, you could also call it. Let me zoom in. Sorry. Get rid of this thing. Okay, so we have the call stack, and then we have these node APIs, and then we also have this callback queue, which is kind of like a call stack, and we have this event loop. So the image we have of we just have a call stack, we put things on the stack, and then we take them off, is a little bit oversimplified when it comes to JavaScript. So we have this other kind of thing where JavaScript can hand off operations to this other thing. So set timeout is one of them. It's a node API or a web API. So when we call set timeout in our code, JavaScript, the normal JavaScript process isn't going to execute this code. We're going to put this on the call stack, right? We got our set timeout function. We put this on the call stack, and then JavaScript is going to say, no, I don't do set timeout. So it's going to hand it off to the node APIs. And once it does that, this call stack is freed up. So JavaScript can keep executing the code. So it executes this code, puts it on the call stack, executes this, and then puts this into the web API or the node API. And then the call stack is freed up so it can keep going. It's going to keep going and it's going to execute this next line of code. Meanwhile, this node API is going to run the set timeout function, which is going to wait some however long you tell it to. And once this set timeout returns, so it's going to basically return a function. So this function, this inner function that we pass as a callback, it's going to stick it on this callback queue down here. So after, in our case, 3,000 milliseconds, this callback function is going to get placed on the callback queue. And this event loop is constantly, you can kind of think of it as just this while loop that's just always running. And the event loop is constantly checking if there's anything in the callback queue. And once this node API executes and this function gets placed on the callback queue, the event loop can check and say, oh, there's something on the callback queue. I need to execute it. But it doesn't just execute it. It has to put it on the call stack first. Or wait till the call stack is empty and then execute it. So if the call stack is empty, then this function can get put on the call stack and then it will get executed. And once it's executed, it can get popped off. So that's why we get, start. This gets put on this gets referred to the web API. Execution continues because this is non-blocking. JavaScript is non-blocking, so you can keep going. This gets executed. Meanwhile, once the set timeout function basically runs, this callback function gets handed off to the callback queue. The event loop is constantly running and checking if there's anything in the callback queue and if the call stack is empty. And if it is, then this gets popped off. This gets executed. So this is basically how JavaScript handles, it's how JavaScript can do things like making a network request while not blocking user actions. Is there a question?
Yeah, Chad, I have two questions. First, the Node API, is that like Node.js or is that just like the name of, is that Node.js or is it different?
Yeah, so yeah, this is Node.js, or in a browser, this will be the web API.
Oh, okay. So I guess I'm just confused on like what if you don't have Node installed, or on
So on a browser, so
yeah.
That's why I was saying Node APIs or the web API. So the web API, this will be part of the JavaScript runtime environment. We talked about that early on, but the JavaScript runtime environment is not just, it doesn't just contain JavaScript stuff. It's kind of a wrapper that includes other things, including some of these APIs. So this set timeout is not, strictly speaking, it's not really JavaScript. It's an API, just like all of these window methods that you can access in the browser. they're, I mean, they don't strictly speaking belong to JavaScript. They're APIs that you can use.
These must be standardized, so all the browser.
Well, so ideally, yes, they would be totally standardized. But this is, I mean, this is a major issue, especially in the very beginning, where you have all these different browsers competing with each other. You know, the so-called browser wars. I mean, even now, getting 100% cross-browser compatibility is very difficult. So there are still multiple browsers and they do things a little bit different, and someone might implement this thing one way or like not implement a new JavaScript feature. So what almost always ends up happening even now is that when you write JavaScript, you can use all the super cool advanced features of the latest version of JavaScript, but that will get compiled down using something like Babel. There's a compiler. It gets compiled down basically into a backwards compatible code. So that's just kind of how things work. So it's not JavaScript in the browser is not a completely standardized thing.
And
it's 99% standardized, but not completely.
And then the second question I had was, like you said that like the event queue gets executed after all the events in the call stack are done. But what if like there's some like events in the call stack still? Like I can envision the set timer at the beginning of the page. Maybe if you do for 3 seconds and you have a lot of JavaScript, then you could have like a lot more items on the call stack.
Mm-hmm.
And then after 3 seconds, it wouldn't execute because then their call stack would still have items on it.
Yeah, so that's a great point, and that definitely can happen. So set timeout is not after 3,000 milliseconds, your code will be executed. What it is saying at least 3,000 seconds later, or 3,000 milliseconds later, this callback function will be executed. So it'll wait 3,000 milliseconds here and then put it on the callback queue. If you have a whole bunch of other long time, like very intensive processes running and the call stack is just occupied, this has to wait. This has to wait for as long as it takes the call stack to empty out. So it could be like instantly or effectively instantly, or it could be a long time. Okay, so
did you run into, like with Python, if you use the naming convention for one of your classes that conflicts with like a default or a package library, do you have that same issue with the web APIs, or are they pretty uniquely named that you don't run into that in JavaScript?
I mean, I don't know that I've specifically run into that issue, but I mean, you could do something like let me try doing this in the browser. So before I do that, there's the window object. Yeah, so it looks like it's not letting me. So let me try. Yeah, maybe it just won't let me. There's probably a way to mess this up, but But in general, yeah, in general, you shouldn't name things the same as a reserved keyword or something that already exists. Okay, so so this is just a general kind of reminder of how JavaScript code gets executed. So this set timeout things, it's still getting executed from top to bottom, but other things are happening effectively in parallel in the background. So let's just do this for the. So now I have console.log start. I do set timeout and I tell it to wait no time at all, 0 milliseconds, and then I do end. So what is my output going to be now?
It's still gonna add it to that extra process, right? So it should be the same.
You think it'll be like this?
Yeah.
Any other? Okay, so let's run. And it is the same because as you mentioned, it still has to hand this stuff off. So this gets put on the call stack. It'll get executed. This will get handed off to the web API or the Node API. Once 0, so basically instantly, it will put this on the callback queue. But by that time, so after the set timeout gets put on this, gets handed off to this, the call stack is empty. So this console.log right here is going to get put on the call stack. So even though this is effectively instant, it still has to go through this extra step. And if something is on the call stack, like this console.log end or whatever, it's going to have to wait. This function is going to have to wait to be executed.
So if you were going back and modifying, for some reason, I'm not sure if there's a use case for this, but if you were going back and trying to modify an existing piece of code, you couldn't just set it to 0 and have it run like a regular function. You'd have to somehow change like the JavaScript somehow and make that a different, almost like rewrite the function almost.
Yeah, so yeah, this is something you definitely have to be careful about. So if I wanted to change the value of X here, and then here, I'm expecting this updated value of X to be there when I do stuff. That's not how it works. It's even more obvious if it's like that. So if you're writing, asynchronous code, this is something we'll see. We're going to talk about promises, but conceptually, this is kind of a weird way of thinking because we typically think of just this. Here's my code and here's how it executes. So I run this and then, I do some processing and I change the value here. And now I'm going to use this new value. So that's not how it works.
Are there other?
You can think of this as almost like a branch in your code where it's going off to the side. So you can't, once this is branched off, the rest of your code doesn't really know anything about it.
Besides set timeout, are there other ones that I think you mentioned things that are coming from the browser as well, or from another website?
Yeah,
are there other things like that? Yeah,
there's a whole bunch. There's a whole set of them. Set timeout, set interval is one. There's a whole bunch. If you just do a search for web API.
Is it the same for user actions too? Like if you wait for somebody to click on something, would that get pulled out to the web API, or does that go to a different something else?
So that won't be, I mean, you'll get a callback there as well, but I don't think that will get, I don't think that gets handed off. What I should, yeah. I should
You'd be
double check
waiting
on that.
forever for the user to click something potentially before some other things could get executed.
Yeah, so that is, I mean, in general, that's an issue. You don't want blocking. You don't want to create blockages. All right, let's move on to promises, because even though it doesn't literally work the same way, it's basically conceptually it's the same. I'll get rid of this stuff.
So if that's not, that whole thing we just talked about, it's not promises, what would you call that whole thing that we just talked about?
I mean, this is basically asynchronous JavaScript.
Asynchronous
So-
JavaScript.
So
Okay.
the general term for what we're talking about is asynchronous JavaScript. So a promise is something similar. It's a way of I want to do something and I know it's going to take, some time to do, but I don't want to block my code until it finishes. So you create a promise. The idea is it's an object, like an instance of a class, and it's basically a state machine. So if anyone knows what a finite state machine is, so it has 3 states. It has this initial pending state, and then it can either be resolved or rejected. So you get this, I want to do something, and I know that at some point I'm going to get a return value. So either the operation that I want to do is successful, in which case it's resolved, it's put into a resolved state, or it's rejected. There's an error or something like that, and it gets put into a rejected state or a failed state. So there are, and once that happens, then you can do stuff with it. But just like set timeout, it's not entirely straightforward. It's not just a linear process. So I can't have, this first line console.log start, and then have a promise in here, and then use the value that I get from the promise in this next line. That doesn't work. So we'll see that in a second. So the basic structure for a promise, it's you create an instance of this promise class, and the promise class, you pass it a function. So with JavaScript, you have to use the new keyword to create an instance of a class. And this promise will take callback function. And this callback function has 2 parameters. One is, and they're actually both functions as well. So resolve and reject. So within the promise, now within this callback function that we pass to the promise, we would do whatever we want to do. So make a network call or whatever we're doing. So we'll just kind of we'll do something like set timeout. I'm going to do this. So we're not going to worry about rejecting right now. So we'll just say what happens when you resolve it. So this promise, create a new promise. And when you create a new promise, you're basically saying, I want to do something. It's going to take a while, but I want to basically keep track of what this is so that I can use it later. You can try running this. So note that this did wait. So we got starts and then end immediately, and then we had to wait a couple seconds. Okay, so we have this value, but we can't just use it directly. So again, there's this issue when you're doing asynchronous programming that even though we think of code executing line by line, this is really, you should think of this as being in a separate branch. It's like in another dimension from the rest of your code here. So I can't, so if I want to do stuff with the value that this returns, in this case, that's this string done. If I want to do something with that value, I have to stay within that same dimension. I have to stay on that same path that this code is on. So the way we do stuff with that, with the value that's returned here, is the dot then. So we have a promise. We create a new promise, right? So I can use that actually over here. So my promise dot then, and dot then, whatever value we get here in this resolve will be available here. So then we'll also take a callback. So notice that we just callback after callback after callback. So you can do, and here I'm going to console log result. Let's try running that. So the output this time is a little different. We actually get this done printed out. So we created this promise. So this stuff is all very weird. So if you're baffled right now, that's perfectly fine. So we create a new promise. It takes a callback function. A callback function has two parameters, resolve and reject. Both of these are actually functions. And what you would do here is actually some kind of logic to, make a request, then check if you get a valid response. Then if you do, you call the resolve method with whatever value is appropriate. And then when you actually want to use that value, you have to call dot then. And then takes a callback function, which you can then access the value from. But notice that from out here in the rest of my code, I can't access this value. This value doesn't exist in the rest of my code here. So if I tried to print, if I did something like, we do maybe here too. So if I try running this, so X is undefined here. This X, I should probably mark this, but so this X is actually undefined. And then in here, even though I'm changing it here, so I can't use I can't use what's happening here in the rest of my code directly, right? This, remember, I mean, the way I like to think about it is this just got, this is now operating in a parallel dimension or in a fork of your code. So even though this is a flat file, this is not really in the same universe as the rest of your code. So we can't access these values directly in the rest of our code. The only way we can do that is by basically chaining on. So we're staying in the same thing, right? This is a property of, this is a method on the promise, right? So we're still in the promise. So we get the result, and then we can console.log the result.
And the resolve function is kind of acting like return in Python.
Yeah, it's basically a way of returning a promise or a value. Yeah. So I can do something here. So if true, whoops. Do this. So we'll set a trigger and then else. Let me get rid of these. What about that now? So I'm going to set this to false. So now this path, so instead of resolving, it will be rejected. Whoops. Yeah. So another issue. So we can resolve and reject. And if we reject it, we need to basically handle that. So dot then optionally can take two parameters. One is what happens if it's resolved. The other is what happens if it's rejected. But the I think the standard is you have a dot then, and at the end you have a dot catch, which is going to be the same thing. So again, I just want to highlight the fact that we are still within this. We haven't left this promise. We're still using methods that belong to this promise. So if let's just say, instead of just an arbitrary trigger, we make a network request and we request some information, but maybe the user is not a valid user or whatever, any kind of check we want to do. If the response is not good according to our application, then we say, nope, this promise has been rejected. So we pass it here and then we handle it down here. If it's good, we make a request and the credentials are good and we can process the information according to the needs of the application. Then we can resolve this value and then handle that here.
Is result a independent? It's just the name you assign to receive the.
Yeah. This could be
So
anything.
it could be anything.
Yeah.
Okay.
And
So
even these could be called whatever you want, but it's basically standard practice to call these resolve and reject.
So kind of going off of what Patrick said earlier, resolve kind of, can we think of that returning to then a successful thing. So resolve will return to then and reject would return to catch.
Yeah, so internally, this promise, this is an object. And so this promise object has a then method, and it has a catch method and a couple other methods. And internally, so there's, this object also has a state, so it can be pending. So let me do so if we just look at the actual, promise itself, we can see that, let me change this to true. So when we take the bad path, just because of the way we've set it up, it gets rejected instantly. So the state of this promise object is rejected. But here it's pending, because this resolve hasn't been called by the time we console log this. So it's still pending. So it starts out pending, and then it either transitions to being rejected or being, I can't think of the name for some reason, but the successful state.
If we wanted to view is it still the parameters of the object, like when you do dir in Python?
Yeah.
Is that?
Yeah, unfortunately, it's not quite so easy to do introspection with JavaScript. Maybe, yeah, later today I can get some resources for that. But
Chad,
this is, yeah, go ahead.
What are the C and the F's doing on 17 and 18?
Yeah, so this is just, this could be, I think calling these result or whatever. So this dot then, so when I resolve, so if I call the resolve function, so I make my network request or whatever, everything's good. Then I call the resolve method and I pass it whatever value I want to use. That's what this is. So then takes a callback, and that callback's first parameter is going to be whatever you pass to this resolve function.
Any recommended references that we can refer to learn about promises, asynchronous, and callbacks?
Yeah, I mean, so I would say that you probably, if your experience is anything like mine, it's something that you'll have to try reading about multiple times from a lot of different sources over some period of time. But the Mozilla docs is good. Javascript.io also has a good overview of promises. But I would suggest, just searching for promises in JavaScript and clicking through a few things.
And I noticed you only had to write my promise once on line 16. You didn't have to write it again on 18. Is it?
So these methods are actually chained. So I've written them on new lines just for the sake of clarity, but this is.
Yeah, it's all one actual line.
Yeah.
You could write
So
it.
It's just like calling
and
map. Yeah, so it's just like calling map. So if I have an array, so I can call that map, whatever. So I mean, just like here, you can chain You can chain these together because this is an array. Map is a method that operates on arrays. It also returns an array. Filter is a method that operates on arrays. So you can just keep chaining the stuff together. So there's another slightly different way. I don't know if you really want to, because we still need to do something else. But so this is one way. So we have promises, and we use .then and .catch. We can chain these. There's also something called async await. So it's basically syntactic sugar on top of this way of doing it. It makes your code look like synchronous code, like regular synchronous code. Yeah, I think maybe we can probably skip that for now, or we could talk about it at the end if we have time.
Is there any
Okay.
crazy with debugging this, Chad? Like I know when it starts doing the asynchronous stuff, does debugging become nearly impossible where there's a different way to troubleshoot problems?
That's a good question. I mean, it does. Yeah, so there are testing libraries that have ways to handle testing asynchronous code, but just as like making something up yourself, I can't think of a good way of doing it offhand. But any JavaScript testing library will allow you to test asynchronous code.
Okay. That's very vague, okay, but okay.
Yeah. I mean, Jest is the one that we'll primarily be using by default. Okay, so I would like to move on to, so this is just intended to be general background, a first exposure to asynchronous JavaScript and promises. And we'll take a short break, and then we will talk about the fetch API. So come back. Let's take a 10-minute break. Okay, so we are going to, I just posted a link to fetch, I think a good overview of how fetch works, if you want to check that out later or now. So fetch is kind of a wrapper, and under the hood it uses promises. So a fetch call will allow you to, from within your JavaScript application, you can make a call, and then you can get some data from another server, and you can use that data in your application. So what we're going to build right now, am I sharing my screen? No. Okay. What we're going to build right now is, so we have kind of a skeleton. This is based on what we've done the last couple class sessions. So we'll end up having something that produces a bunch of little like cards or boxes. So our index.html, you can see we have a currency exchange rates, and we have a select menu, a little drop-down menu. And we have this container div, which is going to contain all of our little items, just like we had before. And the styles, this is all the same stuff that we had before. So we have a container, and we have a bunch of items in the container, which don't exist yet, but they will. Okay, so if we run this, you just get this so far. So we have this currency exchange rates. So we have a web application, and we can choose from US dollars or euros. You can choose a base currency. Okay, so how are we going to get currency information or exchange information? Well, we could hard code it, right? So I could maybe inside the HTML file even, I could just create a bunch of divs, and then I can maybe every morning I can wake up and I can read the newspaper or whatever, and I can get all the currency exchange rates, and I can update my HTML page and then push it to the server, and my website will stay up to date every day. So that's one way of doing it. But that obviously involves, it's very tedious, very time consuming, error prone, all that good stuff. So in order to get this information, say, more reliably or more efficiently, we can use a third-party API. And that third-party API could come from anywhere. We could build it ourselves. We could use someone else's. In this case, we're going to use someone else's. So APIs, so this is a free one that doesn't require any like key or login. It's sometimes hard to find ones that like this. At least for now, this is free and doesn't require any sign up. Most of them will, at the very least, require some kind of key, even if you don't have to pay for it. So we have this API, and here's an example of some of the information that you can get from it. So you have the currency. This is, you know, in relation to euros, so the US dollar and so on. We can go here, this API, and look at the documentation for this API. So the process that you'll always be going through is look for an API. There's something I want to use, or some piece of information that I need to get. Hey, does someone else already have that? Someone else made an API for that? Do a search. If you find something, then you look through it and see, you know, does it meet my requirements in terms of the information that I need and cost and whatever. Then you look at the documentation. So there are standard ways of doing things. We'll talk about that more later. Just REST, representational state transfers. This is REST framework, which is a basic way of designing APIs. So you'll find that most APIs are in, you know, basic conformity, but the details can differ. So you'll have to account for individual variation here. But here we're making a GET request. We have like this base URL here, and then we have /vat, and then a question mark. So what is the question mark?
Query parameter.
Yeah. So it indicates that this is going to be a query string or a query parameter. So we have vat number equals, this is almost like a key value pair. So we can make a request to this server, and we can basically not just, you know, don't just give me everything or give me some random thing, but, you know, I want you to look for this particular entry and then return that back to me. And then the response from the server should look like this. So what is this? What's the format?
JSON.
Yeah. So, you know, 99% of the time, what you'll get back is JSON, but there are other possible formats. So you make a request, and then you get back some information. Now, you could do this synchronously in your application. I could say, I go to my web application, and I want to see, you know, US dollars in relation to US dollars. So I make this request, and then my application freezes because JavaScript is busy, and this network request sends the information out over the network. There's some processing on the server. Hopefully I get a response. And once I get a response, then I can start doing that. I can start moving around and clicking on things and all that. You don't want to do that. So somehow we're going to have to let the user, you know, click on something and then make a request and have that request basically happen in the background. And so the user can continue to navigate around the page. Okay. So we are going to do this. We'll go step by step. Before we've been kind of just making like a script, basically, either just a script or a few functions. We're actually going to make a class this time. So this particular application will be represented by a class. So we haven't talked about classes in JavaScript, but it's not fundamentally different. I mean, we could talk about different nuances, but basically it's the same as classes in Python. So class, I'm gonna call this exchange. So you have the keyword class, and then we have exchange, and then open brackets, and that's basically it. So now we have a class in JavaScript. So we have this class, and I'm gonna just some boilerplate here. So window.onLoad. This will be a function. And something like this. We'll figure out how we can implement this in more detail, but we'll create an instance of this exchange class, and that will be basically available once the HTML document loads. So when we create an instance of a class, one difference from Python is that we have to include this new keyword. Okay, so we have a class. Now in Python, well, yeah, I guess we can talk about the init. So in Python, we have an init, right? So any kind of setup we want to, define the instance, we can run in the init. JavaScript has a similar thing, but it's called a constructor. So a constructor function, and we can define properties here. So unlike Python, we don't have to pass in like self. We don't have to pass in an instance. JavaScript will handle that. So we can talk about specifically what we might want to have, but I'm gonna try to move this along a little bit. So I'm going to, so instead of self in Python, we have this. So this.url. And this is going to be what we need. So I looked at the API. I figured out the information that I needed. So if I go here, I'll get all the rates. So that's fine, but I want to be able to choose between denominations. So in this case, we just have euros and dollars. So here's where I want to actually go, and I can see the example of what I get back. So my base, basically my base URL is going to be something like this, and then depending on what the user selects, depending on user input, I'll make a call to either EUR for euros or USD. So here's my base URL. So now I have this application. So what kind of thing do I need in order to know when the user has done this action of selecting something?
Is it an event listener?
Yes. So I'm going to need, so, we could do this maybe in a couple different orders, but so let's think about the user is going to click here and click on something. So let's add an event listener. So I'm going to add just like a function that will be the main entry point. So I'm just going to call it run. And then down here, so first, before I do anything else, let's just make sure that this is set up. So I'm going to go into the developer tools, and I can see that when I refresh this, I get this running. So everything is connected. My JavaScript is connected to my index.html. And this is all working as expected. Okay, so we need to set up an event listener. So we can write a method. Let's do, I'll just call it drop down. So note here, in a class, you don't use the function keyword. So this is a method. So right here as well. So we can just write these functions directly in here. So I'm going to put an event listener on this thing. So how would I go about doing that? So I want to put an event listener on this. If I look at my index.html, here's the select form.
Would you want
So-
to give the select thing an ID or a class so that you can refer to it?
We could, yeah. So the ID. You can do that. And then in general, so we haven't talked about, forms and stuff. So you don't have to tell me exactly how to do it. So I'll fill in details. But in general, what's the process we have to do if I want to put an event listener on this?
Use the DOM to assign that that ID to a variable so that you can do things with that variable.
Okay. Equals document dot query selector. We called it selector. And once we have this available to us, we'll have to add an event listener. So selector add event listener. And there are a whole bunch of events. I'm going to use change. And so this will take the event and also a callback function. And that callback function will get the event, which we might not need to use. Might not need to use. So I'm going to put an event listener on here. And then for now, let's just do okay, so if I choose this, so I'm going to need to actually call this function. So let's do that. So run, it's running, and then we will do. So how do I refer to a method from within the class?
This dot drop down event listener.
Yeah. So this dot drop down event listener. So that should run. Add event listener of null. Let's try. So I did something wrong here, which is I need to tell it that it's an ID. So when I change the value here, the event gets triggered. So I can access the event. But I don't just want, the event. I want to see if it's, if I want to see what they clicked on. Is it US dollars or euros? So I can do event.target.value. Let's try doing that. I can see I get US dollars or euros. So you might have to play around, depending on like the kind of input you're using, you might have to play around with how you get it, but that's the basic idea. Okay, so now I have an event listener and I can actually get the user input. So once I have the user input, I'm going to need to make a network request, right? So rather than just logging the event here, we're going to need to call. We're going to need to make a network request. So let's write another. Let's write another method. We'll call it. You know, something like that. And that this function, the get currency info. Let me call this, I guess. Something like that. So we're going to need to make a request. We'll use the fetch API to hit this endpoint, but we're also going to want to pass in whatever the value is here. So we'll call it the currency. We're going to take in the currency. And then we'll make a request. So you can do something like fetch takes a basic get request for the fetch API. So we'll do this.url plus currency. So if we want to go to this equals USD or this equals EUR. Okay, so this is not going to work by itself, but that's a start. So let's now call this function. So exchange this dot exchange API call, and we'll pass it e.target.value. Okay, so we add this event listener. We're gonna listen for a change event. When that change event happens, we'll log it, and then we'll call this exchange API call method. So when we call this method, we're going to make a request. So let's just try. So one side note, as you're developing, so we're using a free API, just be careful about making, like a ton of requests rapidly. So don't put your fetch in a for loop that runs 1,000 times or whatever, because you can get blacklisted. Okay. So I click on USD. I can see that the event got triggered, and I make that fetch request, and I get back a promise. So I can't directly, unfortunately, I can't directly do anything with this. It's just a promise. It's telling me that. So again, fetch is a wrapper. It uses promises. So just like we saw before, so we have this promise state. It has a state of pending or resolved or rejected. So I can't use this directly as it is. I'm going to have to do some further processing. So I could do, I could add .then. But I'm going to show you just an example of using the async await syntax because it makes it much cleaner. So the first thing you have to do is there's this pair. So async await. So if you have a function where you want to use a promise, so here we have res is going to be a promise. So we have a function and we want to use a promise. First thing you have to mark the function as being an async function. So you just include that keyword, async function. So now JavaScript knows that this is going to be an asynchronous function. Okay, so we have the async function, and then the pair for that corresponding pair is await. So what we need to do is we mark the function in general as an async function, and then if we want to use this value anywhere else, we need to mark this as being await. So this is gonna return a promise. So we need to await the promise, and then that way we'll be able to. We'll see the difference here. So we didn't just get, a pending promise. We actually get a response. So we'll need to do further processing, but because we've marked this as this function is async and we awaited this, now this value, it's not just going to be a pending promise, it will be whatever that promise returns. But again, I just want to emphasize that this async await is just, convenience syntax. You could do the same thing with dot then, response, and then whatever processing you want to do there. So it's the same thing. This just is cleaner looking. Okay. So we have this response, but you don't need to worry about this, but the way this works is you'll get this promise will get resolved as soon as the headers come back. So it'll get resolved when the headers come back, but it won't, not when the whole content of the body. So you actually have to do another step. So so this is just a peculiarity of the fetch API. So you're gonna have to do these two steps. So you make the fetch call, and then assuming you want to use something other than the headers, you'll make another. So this will return a promise, and then you do the same thing here. So you'll have to await this, and then once you get the res.json, you can console log this. We actually get back this JSON object, which should look roughly like what we're told it looks from the documentation. Hopefully the documentation is accurate. So we get this. Okay, so we have all of this data now. So we've made this asynchronous call to fetch the data, and we now have JSON that we can use. But that's not, that's not, so almost all the time there's going to be a processing step. So I make a call, I fetch some data, I get some JSON. I'm going to need to do something with the JSON. So ultimately, what we want to do is take all of these. Take all of those rates, if you get here, and turn them into like little cards on our website. So just a bunch of little boxes that have the denomination and then the value. So in order to do that, we're going to have to do some more processing. So I'm going to first off, I can tell from the response that I got that the information that I want is in this rates key. So let's take a look at that. So now I'm just getting this information that I want here. I'm going to go ahead and return as JSON.rates. Okay. So I have, again, I put it in event listener. I'm looking for this change event. Once I do that, I make a call to this API. And then I'm going to get these rates back. But I don't just need the rates, I need to process them and then turn them into HTML. So I'm going to need some kind of function. So I have a value here, but I'm going to need something else. So I'm going to create another function. The function will be, let's see, we'll call it, we'll just call it API wrapper. So I'm going to do this. And instead of calling this here, I'm going to do we don't need that function keyword. Just some refactoring here. Okay, so now I have this event listener. When the event gets triggered, it's going to call this API wrapper. It's going to call this function, which is going to give me a this value right here. So let's try we'll console log it. And what's happening here? So this is a common issue you're going to encounter when you start using promises, is that once you start using promises, you can't stop. So this is going to have to be async too. And we're going to have to await this. So now we actually get back what we need. So because this is now an asynchronous function, if we want to use a value, we need to await it, which means that this function needs to become async. So you have this very, promises, returning promises thing. Okay. So now the good news is that we have access to the raw rates. So we're going to need to process them. So I'm just going to kind of blow through this because this is just, basic JavaScript, not really related to promises. So let's have a new function and we'll call it pass in the raw rate. So let's process the rates here. So we're getting basically like key value pairs. So what I'm just going to copy this so I don't have to. spend too much time on it.
And Chad, you don't have to await process rates because it's being called inside the async function.
It's because this function, which we haven't written yet, which is right here, is not an async function. So this function is a synchronous function. So we don't need to await it. I know it's confusing, but so this whole function has to be marked as async because this function that we're calling, exchange API call, is an async function. So if we want to use this value, if we want to wait for this value to come back in to be resolved, then we have to mark this as a wait. Once we have this value, then I can call just a normal synchronous function normally.
This is definitely a rewatch lecture. Hopefully you upload it. I'm gonna rewatch it again before I even try a challenge today.
Promises, again, promises are not something you're going to get instantaneously. It's a new way of thinking about it, and arguably it's not, it's definitely not intuitive for sure. So that's why we're doing this exposure. We'll see it again later. So being able to make API calls, you don't strictly speaking need to understand this. You basically just, there's like one common pattern you'll see, which is fetch the data, convert it, and then do something with it. So if you do it a couple times, you should be able to do it even if you don't have a deep understanding of how it works.
That's what I normally do when I rewatch your lectures. I'm gonna code with you as you code, but I can hit pause where right now you kind of lost me a little bit ago.
Okay. Yeah, sorry about that. I'm trying to not, it's already, 10:40.
Oh, yeah, you'd have lost me no matter what. It's fine. I wasn't a negative. Fine.
Yeah. Promises. So again, I just want to emphasize that promises are something that will probably take several passes to understand, or at least have a basic understanding of. All right, so we have, we're getting this raw information from our API call. Now we want to process it. And in this case, we're going to turn this into some HTML. So I can not print. Something like that. All right. Let me see here. Right, forgot that. Let me change this to this will be so object.entries. It's like in Python, it would be like dictionary.items, whatever. So this will just, we'll do pairs. So that should work. So this is not going to be readable, but we'll be using this to insert. So we're kind of like generating HTML for every single entry that we get, so that we can display it. So now we have an array of basically paragraph tags that contain information about the this is the currency name and then the currency value. So again, just to recap here, we're putting an event listener onto this thing right here, onto this drop-down menu. When the event occurs, when there's a change event on that element, the API wrapper function is going to get called. That is going to call Exchange API call method, which is going to use fetch. It's going to get some JSON back, and then it's just going to grab the particular part of that JSON object that we need. Then once we have the information that we need, which is going to be in an object, then we're going to process that. And when we process it, we're going to basically take all of those key value pairs and turn it into an array or array of arrays. And we're going to map over all of those entries and turn them into p tags. And we'll eventually insert those p tags with the information into our HTML page. Okay. So here we are, the API wrapper. We have the processed events. Okay. So once we have all of these, then we're going to want to go through and create a bunch of items. So a bunch of cards, basically, will be populated. So we can go here and let's do and that will take the process rates. Okay, so I'll create these cards, and then just like we've done before, I'm just going to have a for loop. I'm going to loop over for every entry that we have here, each one of these. Yeah.
Are you calling process rates twice, once on 17 and once on 18?
Yes, sorry, this should be, thank you. Yeah, so we're processing the rates, and then once we get the information processed, ready to go, we're gonna create these cards. So here we're going to loop through every single one of these that we have, and we're going to create a card, and we're going to insert this into that card. So we can do for I equal 1, let's say, actually it doesn't matter in this case, let I equal 0, while I is less than process rates dot length, I plus plus. So now we can, for every single one of these, we can do something. So we will, in order to create a card, we're going to have to attach it to something. So in our case, that's going to be this container. So what I'm going to do is I'm going to add this as another part of our constructor. So this dot container equals document dot query selector container. And then I can do something like, so I'm going to, for each one of these, I'm going to create a new card. So this will be from the items. If we look at our CSS, this is the item. So we're going to create a bunch of these. Document dot create element. We'll create a div. Again, you know, talk about accessibility, it's not ideal, but okay, and then so once we create this div, we want to give it this class name. So we don't have to specifically enumerate all of the CSS properties. We could just, if we have it predefined in the style sheet, all we have to do is put this label on it and it will pick up all of the properties. So let's do item dot style, what is it? Class name equals item. And then, so we have all these processed, right? So what I'm going to do is item dot inner. I'm not recommending this as the best thing necessarily, but we can do this. So it's the reason I created this HTML here. So item.html inner HTML equals process rates and I. So again, we generated a bunch of these, and now we're saying we're going to create a div, and we're going to make sure it has the class of item, so it will show up as like a little grid. And then inside of that div, we're going to insert this paragraph tag. And once we have that, we're going to append it, or yeah. So this dot container dot append child will append item. So let's see how that works. So now, zoom out. So when we make this API call, we can dynamically generate the content on our page. I can refresh. So this is US dollars. I can refresh this. There are other things we can do to obviously make improvements, but euros. So now euro is up here, the value of 1. So we have all these cards. This is from the items class name. And then the specific content we're getting here, that's coming from our API call. And depending on when this API that we're using is updated, that will mean that their application is up to date. So if this, you know, if their API gets updated every 10 minutes, then our application is effectively updated every 10 minutes as well.
What happens if you choose another base currency without refreshing?
It will add on. So there are definitely things we could do to improve this, but I think I can paste. I actually have some of that written up, so I can paste this in a GitHub. Just if you want to take a look at something slightly more robust, but this is the basic idea. So it's possible to generate HTML dynamically leveraging a third-party API, which is basically what you're going to be doing. Whether you're creating your own API or using third-party APIs or doing a combination of both, you'll be doing a combination of both. So aside from so when we get to React, so this is not, you know, a React application, but React will use either a class or a function to kind of represent a component. So it's similar to what we're doing here. We've taken all this functionality and we've placed it inside of a class that we could potentially reuse elsewhere. Are there any questions about what we've talked about? I know that I'm sure there are a lot, but.
Can you make a class asynchronous too? I'm just curious.
I don't know. I'm not sure. I'm not. You might be able to make the constructor asynchronous. I don't think you can make an entire class asynchronous, but there might be some workaround where you could make a constructor asynchronous. I have a vague memory of trying to do this.
I agree with Jeff. I'm gonna have to rewatch this video and do code along, and I'm gonna have to go over some of these concepts that you covered, like promises, async, and all these fetch APIs in more detail.